Hello scientific brilliant people, how are you today? So today I'm going to solve question number 12.7 and this is of grade 12 NCERT textbook and chapter is atom, problem number 12.7. Okay, so here they are asking us to find out the speed of the electron in first, second and third orbit, and we are also supposed to find out the time period for all of these electrons in these different orbits. So guys, I have already made videos on Bohr's atomic model. So the radius expression is the most important expression that you must be able to derive, and the energy expression as well. So the link to those two as well as the how to derive the time period expression are given in the description. You can check those videos first before attempting the problem. Okay, and as far as the velocity is concerned, I'll derive it over here. It is not going to be taking much time over here, right? So let's start the velocity expression first. So we know that the first Bohr's postulate is equal to nh upon 2 pi. This is mvr. So mvr is equal to nh upon 2 pi, and from here velocity can be written as nh upon 2 pi, nh upon 2 pi, and m and r are going to go over here. So this is our velocity expression, but still we have to substitute the equation or the value for the radius, and we have derived already that radius expression for electron in the nth orbit is equal to n square h square upon epsilon 0 pi m z e square. So this is our radius expression, guys, and I'm going to substitute it over here. So velocity equation for electron in the nth orbit will be equal to nh upon 2 pi m into 1 upon rn. This is 1 upon rn. So I'm just going to do the reciprocal of this expression, pi m z e square upon n square h square epsilon 0. So now I'm going to cancel the 1n from here. Mass of the electron, pi gets cancelled. Now what else is getting cancelled over here? H z e square. Okay, now nothing is getting cancelled. So let me write down the final expression for electrons velocity in the nth orbit. That is equal to z e square upon 2 h square epsilon 0 square times n. So basically it can be written as multiplied by 1 to n. So here, as you can see, that rest everything is constant, so we can say that velocity expression for electron in the nth orbit is proportional to z upon n. So if you are selecting a particular atom then of a particular element, then the z will also become constant. So for that, under that situation, velocity is directly proportional to 1 upon n. So that means as an electron keeps on going to higher and higher orbits, the velocity is inversely proportional. So as n increases, v decreases. So now this is the velocity expression that I am going to use in this question over here. So here in this question they are asking us to find out electron's velocity in first, second and third orbit. So let us find out that. So just now the velocity expression derived was v n, that is equal to z e square upon 2 h square epsilon 0 square n. So for first orbit n is equal to 1, and they are talking about the hydrogen atom. So for hydrogen atom z is also 1. So E is 1.6 into 10 raised to minus 19 and its square. I am going to substitute everything in the SI unit, and this is 2 multiplied by H is 6.62 into 10 raised to minus 34 in SI unit, its square, multiplied by epsilon 0 is 8.85 into 10 raised to minus 12, again whole square, and again n value is equal to 1. So guys, if you solve this in the calculator, you will get the value. So guys, on solving this one, you are going to get V1, the velocity of the electron in the first orbit, to be 2.18 into 10 raised to 6 meter per second. So electrons, they move around the orbits with a very high speed, and now since we have already discussed that V is proportional to 1 by n, so this is the electron's velocity in the first orbit. So if the electron goes in the second orbit, the electron's velocity will be half of the first orbit, right? So because V is proportional to 1 upon n, so V2 will be simply half of this number, and if you solve this, you will get this as 1.09 into 10 raised to 6 meter per second, and the electron in the third orbit will have 1/3 the velocity of the electron in first orbit. So V3 shall be equal to 7.27 into 10 raised to 5 meter per second. So these are the three answers to problem A. Now since the time period expression B, I have already given the link in the description, so you may find the proper explanation over there of the time period. I am just going to write the equation over here. So time period expression for an electron in the nth orbit is given by 4h cube epsilon 0 whole square upon m e raised to 4 into n cube upon z square. So from here, as we can see, that time period is proportional to n cube if everything is considered constant, even for a particular atom. Since we are given atomic number of hydrogen is atom to be constant, that is the hydrogen, so z will be 1. So for the entire expression, entire this problem for n is equal to 1, 2, 3, this time period, this z is going to remain 1. So now you can also say that as time period, suppose time period of an electron in the first orbit is t1. So for the electron in the second orbit, the time period would be 2 cubed times t1. So it would be 8 times the time period in the first orbit. And time period of an electron in the third orbit would be 3 cube of that of t. So that is 27 times the time period of an electron in first orbit. So let us substitute the value of the necessary values, and n is equal to 1. I would be calculating only for 1, and rest this will follow. So 4, and h is Planck's constant, so 6.62 10 raised to minus 34 whole cube, and this is 8.85 into 10 raised to minus 12. Everything is in SI unit. This is square. N and Z both are 1 for electron in the first orbit, for hydrogen atom. This mass of the electron is 9.11 into 10 raised to minus 31 kilogram, and multiplied by charge of an electron is 1.6 into 10 raised to minus 19 coulombs, and that too 4 times. So guys, be very careful in the calculation, right? I have already solved this problem, so directly I am going to write the answer. You may choose to do it with the help of calculator and verify this answer. So the time period of an electron in the first orbit would be 1.522 into 10 raised to minus 16 seconds. Now this is the time period of an electron in the first orbit. So for the second orbit, I am supposed to multiply this number by 8. So I am going to get this answer as 1.22 into 10 raised to minus 15 seconds. And time period of an electron in the third orbit, I will have to multiply this number by 27. So that answer would be 4.11 into 10 raised to minus 15 seconds. So hopefully guys, this works for you. Thank you for watching the video.